After writing my children's book, Funny Clouds, A Chemtrail Tale, and taking on trolls and the alleged debunkers face to face, I learned that some of the nuances of the chemtrail argument were, right or wrong, dead ends. I looked at all the narratives, spoke with various chemtrail community leaders, and hosted a podcast that explored the issue away from any gatekeepers. I learned a few things and even made an original discovery that no one else in the world had quite yet put together quite so specifically. First of all, I learned that the big secret all sides of the narrative were missing was that water vapor and not CO2 was the most prominent greenhouse gas on Earth, and that not only are billions spent on covering this up, but that this is and has the most significant impact on climate according to NASA, who says even small changes in the abundance or locations of clouds could change the climate more than the anticipated changes caused by greenhouse gases, human-produced aerosols, or other factors associated with global change. I also learned that, despite being able to prove that planes are dropping chemicals in their fallout, which planes are dropping which chemicals is impossible to prove. This is why the public is allowed to have the chemtrail narrative. It is a safe narrative. Sure, it's on the alternative side of things, but it is very controlled. In fact, not only is it a safe narrative, but it is a desired narrative, because the truth of the matter is that all contrails are chemtrails. Repeat, all contrails are chemtrails. Those contrails are not condensing on pixie dust, darling. Not realizing this neuro-linguistic programming trick of language allows aviation to get away with monstrous pollution, which, if checked, would make it harder for them to get away with the weaponized aspect of the program. Another NLP trick is the use of the term stratospheric aerosol geoengineering. What we are seeing on a daily basis, practically now, is tropospheric aerosol geoengineering on the boundary beneath the stratosphere. I soon realized that Weather War 101 was the only one who could explain and prove where severe weather events came from each and every time a community was taken out by one. While everybody else was talking about chemtrails you couldn't catch and or the HARP facility in Alaska you couldn't get to, this guy, whoever he was behind his masked anonymity, was on the ball. Power plants releasing massive amounts of water vapor synchronized with other plants, fed into the hydrological system, guided by Doppler radar. After interviewing Weather War 101 and getting some traction exposing his work, I made my own illuminating discovery in the last 2017 hurricane season. That the eye of all the storms go directly into Doppler radar and have for years now. Just how many and for how far back exactly remains to be seen, as the research is still in progress, but the entire 2017 hurricane season followed this discovery's trend. Was this why I was able to interview a former Army captain in charge of gathering supplies and get his testimony that he was ordered to bring as many body bags to New Orleans 11 days before Katrina made landfall, and that he brought 5,226 body bags 8 days prior, even though I didn't know about the storm until 3 days prior to landfall? Was this also why a source in the military in Texas told me, before the general public was told about Harvey's existence, that he was told to pack his bags before the storm was even a tropical depression? After getting a heads up for Harvey, I discovered the eye of Irma going directly into Doppler radar when making landfall and following this trend all the way inland. I followed Nate, Maria. They, too, followed Doppler, eye for eye. Our team went back to Katrina and discovered that it, too, was Doppler bait. At least 5 Doppler radars in a row, in 3 states. This, along with the guidance of chemtrails to manage the fronts, is how daily weather is made and has been for years now. As incredible and certainly crazy as it all sounds, this is where our research has taken us. This trend surpasses tremendous statistical odds, and if it continues to prove to hold up during the rest of our research, will be the Achilles heel that all the gatekeepers will want to guard against the most. We feel that there is another component at play to create and direct monstrous stream over the oceans, but as of yet cannot be sure of what exactly, though it may employ satellite or drones outfitted with lasers of some type, or a steam-making ship. But I doubt it's land-based. However, while on land, the hurricanes interact with radar just like the other weather events, except that the hurricane steering is the most damning. What does the meteorological community have to say about all this, you may ask? Great question. The answer is, unfortunately, nothing. At least to the public. After trying to get my meteorologist to answer questions about chemtrails for years, she finally offered to run a story on albedo modification and contrail pollution after I asked her to actually define the conditions that allowed a contrail to form versus those required for it to persist and form jet cirrus. She admitted that she can't. At least, she offered to run the story until the woman at the National Weather Service and NOAA she referred me to answer my questions she couldn't, told her to can the story. I learned from them both that there is nobody at the meteorological level that is expected to tell the public the truth about artificial clouds or weather. In fact, the NOAA reports to the World Meteorological Organization that no weather modification projects were conducted in the United States, even though the World Meteorological Organization states in the same report that hydrological companies have been at the cloud seeding game the longest, 50 years, ongoing. I asked the lady why the lack of reporting by the NOAA, and she said they were not obligated by law to report on activities publicly. I said, y'all did in the past when you were not obligated, so what changed? Crickets. I asked, whose job was it to notify the public of artificial weather? Crickets. I asked, why is Doppler appearing to steer the storms? Crickets. I have found that the best way to advance the narrative is to not make claims, but to see what the official narrative says and to hold it accountable to itself, to see if it holds any water and make waves that way. So since it's nobody's job to answer to the public about artificial clouds or weather, then it's up to me to find out what is going on. Seeking better answers, I go right to the source. All right, there it is. The Austin Convention Center, the site of the 2018 American Meteorological Society Conference. And we're hoping that picking up our press pass goes smoothly. I'm a climate science follower and climate engineering concerned citizen, climate change concerned citizen. I find that there's a part of the story that is missing, and we're going to go ask questions about that now. Come along. To be completely honest, after 7 years of investigating the issue and seeing how hard it was to engage others in it with any intellectual honesty, knowing that the subject of weather modification, deliberate or accidental, in any cadre outside of cloud seeding, is social, professional, and or political suicide, I was a little shy. So, the first day I just attended a lecture for my further research in mixed-phase clouds, before going down to the posters hall where a reception entertained us attendees until the opening ceremony for the convention presenters officiated the commencement of the conference. I gently and gingerly felt my way amongst a few people preliminarily and found out that the warm reception my smiling curiosity brought me turned to eyes quickly and withdrawn friendships once the line of my questioning became apparently more pointed in a direction that questioned the narrative rather than that of one that embraced it. I asked 3 questions to 3 separate people along 3 separate lines. 1. The contrail phenomena. What's the difference between geoengineering plans projected in the future for the stratosphere and the almost daily geoengineering we are seeing in the troposphere? 2. Anthropogenic clouds include power plants. Why are wet surface air cooler releases feeding into storm systems and ignored by local meteorologists, even though they have historic weather modification significance and precedence? 3. Why does Doppler radar appear to be guiding storms and steering hurricanes around by the eye? Is that inadvertent or deliberate effect? All these questions are outside of the fact that whether this is a deliberate or accidental weather modification, we do not care. We just want accountability. Either way. Ironically, outside today of the American Meteorological Society's annual conference, the only weather we have is the contrail cirrus that has fanned out and taken over the sky in the Austin skyline here. This is Tuesday. I don't know if it's the 9th or 10th of January, but it's... Oh, that one is a quick disperse. Doesn't linger like some of the others. That's a very long... See, these are chemtrails too. These are quick disperse. They definitely supersaturate the sky. Star shape. Even these clouds are built up, accumulated jet cirrus. Clouds that wouldn't have been otherwise. Having had a dear friend and fellow activist remind me the night before that I was there with purpose representing millions of legitimate people who are concerned about climate and climate engineering, I gathered my courage and went up to the lecturers determined to ask my questions.
Good morning, everybody. I am not Gopal. I am Gus Alaka. I will be filling in for him today, talking a little bit about HFIP in the 2017 season.
Since the details of a lecture that discusses predictive weather technologies are irrelevant to someone who has discovered how hurricanes and weather are steered already, I decided to let my question inform the presenter how he can learn to better predict hurricanes and see what he has to say about it, since the whole discussion was on finding better means of predicting hurricanes.
So I'll leave the conclusions up here. I went over time, but I think the main point is this is the pathway to the next generation. That's what HFIP Stream 2 really is. And so the capabilities showcased in Stream 2 will help guide developments to the next generation FVGFS, the H4 moving nests from basin scale, the large hurricane nest with uniform resolution from the nested FVGFS, and probabilistic forecasts from the H4 fund sample. So thank you. I'll take any questions if we have time.
We're still ahead, so we have plenty of time.
I didn't need to rush.
Well,
In that
never
case,
know until the end.
in that case, I have notes.
I didn't know how many slides you had. Are there any questions? Yes, in the back.
Raphael O'Neill, Liberty Beacon. I'm a climate science investigative journalist. I knew about Harvey before it was named tropical depression because I have a friend in the military who told me he was told to pack his bags in Texas. I started paying attention and I couldn't help but notice that Irma was coming right into Doppler radar. And then I correctly predicted it would probably continue going right into Doppler radar. And that is indeed what we saw. And then Nate, I live in New Orleans, and I'm also a victim, survivor of Katrina. I've buried a lot of friends at the time and in the years that followed. As a result of that, severe weather has consequences. We saw that Katrina had 5 Doppler radars in a row. The eye of the storm going for 5 Doppler radars in a row. If you want to predict weather, start paying attention to Doppler radar. Because Irma, Nate, it was going into KLIX on the top of slide L. We would love to know what besides coincidence, because we're getting a statistician team figuring the odds of that happening, which are right now, every hurricane we've looked at, we're still in the process. This is new, we're late people, I do write on the subject of anthropogenic clouds. I find that water vapor in general is dismissed from the public narrative, and I'm sorry to bring this up, but this is kind of important, and you guys are in a predictive hurricane field. So what do you think is going on there? Is there a possibility that the technology is interacting and drawing the weather inadvertently?
First, let me say I'm definitely not an expert on this topic in terms of the technical details of Doppler radar, but I don't know any studies that are talking about technology drawing these storms.
Well, I've seen the patents, so if you'd like to look at them, I'd be happy to show you.
I'd be happy to look at them. I'm just letting you know, ma'am, I'm not an expert on that topic, and I'm not aware of any studies, if anyone else would like to correct me here, any studies that have been peer-reviewed that show that.
You may want to include that in your studies in the future. Thank you.
Yes, ma'am. Thank you.
This will be an odd one to follow. Anybody else? All right. Thank you very much. And
landfall of this hurricane is imminent. It will happen in the lower Florida Keys, more likely not in Key West, but another one of the...
All right, here we go, guys. The storm is being guided, okay, from NEXRAD to NEXRAD. The eye is going right towards the NEXRAD centers. Here we go. Gonna have to re-add that to the edit. Let's see if we just keep ping-ponging from NEXRAD to NEXRAD. So far, every storm takes place over NEXRAD Doppler radar. No meteorologist has noticed? None? Here we go. Whoop, 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 whoop. Yeah, got a little beam. Suck it up, baby, suck it up. And then let's see what other... Wow. So it's just a matter of which NEXRAD they activate for it to follow the path. It could totally go to the East Coast. It could totally go to Louisiana, Texas. It can go to the North Pole for all I freaking know. It all depends on what the NEXRAD is doing. I mean, what are the odds it would go right from NEXRAD to NEXRAD?
You know, they were talking about climate change yesterday, and now we're learning that scientists and researchers are looking at how to change the weather on purpose. That's right. Lasers now could one day manipulate rain and lightning. CBS This Morning contributor Michio Kaku is a physics professor at City College of New York. Professor, nice to see you. Extraordinary seeing Al Gore and Bill Clinton there together with Charlie, wasn't it?
That's right, yeah.
Yeah, they did not get into this discussion,
no.
though. But it is fascinating. I mean, lasers, really, to change the weather?
That's right. Well, as Mark Twain once famously said, everyone complains about the weather, but no one ever does anything about it. Well, instead of doing a rain dance, we physicists are firing trillion-watt lasers into the sky to actually precipitate rain clouds and actually bring down lightning bolts. This is potentially a game changer.
But this is experimental.
It's experimental. However, in the laboratory so far it works. When you have water vapor and you have dust particles or ice crystals, you can precipitate rain. It condenses around the seeds. These seeds can also be created by laser beams. By firing trillion-watt lasers, you rip apart the electrons, creating what are called ions, and these ions act like seeds, like dust particles, bringing down rain and even lightning.
Go ahead.
Well, this fascinates me in part because, too, I remember reading the stories that China had used this during the Olympics, that the USSR had used this after Chernobyl to create rain clouds. I mean, did those really work then? We have some of these capabilities now?
Inconclusive. Even in the 60s, the CIA used this to bring down monsoons during the Vietnam War, to wash out the Viet Cong. Governments have been playing with this thing.
Alleged to.
Alleged to, right.
Yeah.
Now,
my name is Ben Livingston. I'm the first person to ever see the cloud with the intention to cause it to do military damage. I know I can say that, and I did it several times before the next person did it. Well, the Joint Chiefs of Staff had been wishing for quite some time, in terms of years, that they had some way of slowing the trucks down in Vietnam. That led me to advise the Joint Chiefs of Staff that we had a potential weapon system, and so I was asked to start to put together a top secret operation to go to Vietnam to see if we couldn't make it rain more over there as a military operation. All the roads over there were dirt roads, and when it rained, it caused them a lot of problems. So that during the monsoon season, there was so much rain and water in the roads that the trucks really couldn't move very freely. Our mission was to make it rain during the dry season. On that particular day, the clouds were very small. There just weren't any real big thunderstorms or anything like that. But I picked a cloud that was sitting out essentially by itself with a number of small clouds. I'm talking about clouds whose tops were somewhere near the freezing level, but not high enough to really grow. And I nurtured one of those clouds until it finally got it in well past the freezing level, and then the cloud developed a lot of convective activity, and it started sucking clouds into it, just building up and building up. And I took a series of pictures what I called for 41 minutes. By the end of 41 minutes, we had flown up to over 65,000 feet, and we still couldn't reach the top of the cloud. So we knew we had a barn burner there. And by the next morning, we had washed out everything in the world and did a lot of damage to people and all that sort of thing. But it was a real success as far as blocking the roads off. With just two of us involved, myself and a civilian, but we conducted that operation with aircraft, military aircraft, mostly from Marine Corps, and then shortly thereafter we started involving the U.S. Air Force.
We realize that for decades now, these governments have been alleged to have experimented with weather control, but nothing conclusive. This time we're bringing in the laws of physics rather than simply waving our hands and uttering mumbo jumbo. We're actually using trillion-watt lasers now. And in the laboratory, sure enough, they precipitate rain out of water vapor. Sure enough, you can actually bring down electricity down the beam.
Incredibly interesting. Professor Michio Kaku, thank you so much.
My better next guest doesn't even need much of an introduction, but John Nielsen Gammon is the state climatologist for Texas, and he's going to give us a look at the exceptional rainfall that we had from Harvey. Thank you, John.
Okay, thank you. Thank you for the opportunity to speak here. My objective here is to give you as many opportunities to say wow in 11 minutes as I possibly can by talking about many ways in which Harvey was exceptional. Talk after mine is going to talk about climate change aspects. This talk doesn't directly imply anything about climate change, except to the extent that some people have argued that the storm wasn't exceptional and therefore couldn't have been caused or affected by climate change. And so I'm going to tackle the first part of that argument. First, an overview of the rainfall event. These are 24-hour accumulated rainfall totals from the River Forecast Center Stage 4 precipitation analyses, Harvey making landfall on 25th. The white is precipitation exceeding 10 inches, and the main point looping through this is that it was producing very large amounts of rainfall day after day for in roughly the same location And that's the main bottom line for why you see so many exceptional records. So one point of comparison, if you use the Applied Climate Information System, which is a database cooperative endeavor by the regional climate centers and National Centers for Environmental Information, you can compile a list of the all-time record monthly rainfall totals for any place in the southern United States. And this is the complete list through 2016 of all records that exceed 35 inches of rainfall in a single month. Mount Mitchell, North Carolina tops the list with almost 47 inches of rain back in September of 2004. I want to compare this to the storm total precipitation for Harvey from the same database. Here's that list. Many more observations of the single storm than overall records of monthly rainfall for the past century plus. Some of this difference is due to a lot of observations in the metropolitan area of Houston from Kokoros. So I'm going to merge those two lists just using co-op and network observations. And still, even in that regard, we had one storm total that exceeded the previous monthly rainfall record for the entire southern United States. 6 out of the top 10 of these on this list are the Harvey rainfall totals. So single event meeting or exceeding all-time records for all events within a given month. What we're working on right now is trying to basically compile a definitive database of all the rainfall records or rainfall observations during the storm, whether they're official or social networks or just backyard gauges. If anybody's got data, we would like to compile it and produce a range of analyses of rainfall for the storm, which can then be used to validate hydrologic models and radar estimates, and even do such things as compare how different choices of analysis produce different results, how different instruments measure heavy rainfall. It's pretty rare you have an event that has widespread very heavy rainfall, so we presumably have a pretty good signal-to-noise ratio here. So for all these reasons, we're trying to use Harvey as an excellent case example, and we of course welcome all available data and also anybody who'd like to contribute their own analysis using our data. Exceptional weather deserves exceptional attention. So thank you for your attention.
Do we have any questions for John? Here's one coming forward. Raphael O'Neill, Liberty Beacon, investigative journalist and survivor of Katrina, appreciator of severe weather and what it does, effects that are ongoing. I was actually aware of Harvey before it was a named storm because I have a friend, a source, who is in the military who said he was told to pack his bags. He's in Houston. And I paid attention during the season that we actually saw Harvey being refueled multiple times on land anthropogenic clouds from cooling towers. This was a studies being done in the 70s and 60s and 80s, but the narrative these days can omit anthropogenic clouds from power plants. And in Louisiana, we had the 1,000-year flood, which we also saw on radar having these massive plumes that correlated with the cooling towers and the power plants. Impossible to get a meteorologist to have a conversation in person, so I appreciate you opening the conversation to the public to put in their input. What do you think is there any studies? I mean, I know that the former president of the AMS, who passed away, rest in peace, was working with groups that study meteorology around power plants. What is the current state of those studies? Do you know what are the effects of cooling towers on our weather? Who is actively studying that? Because we are noticing that, and there are people that have researched this for years.
Yeah, thanks for the question. I can comment a little bit on that, which is that the main effect of such towers would be in occasions of more isolated precipitation rather than widespread precipitation. In the case of Harvey, we had precipitation occurring simultaneously over wide areas, so the cooling towers would not have played any role in initiating precipitation. Their only role would have been in adding moisture to the event. And to that extent, the only amount of moisture they added would be the amount of water evaporated, which would have been a minuscule contribution compared to what was being evaporated from the ocean and being pumped in. But that is not the only anthropogenic contribution potentially in this case. You notice in the rainfall maps that there's a gradient of precipitation from ocean to land. And some work by Danny Rosenfeld, for example, has shown that there's a possible contribution to the microphysics of the storm from the difference in aerosols, both biogenic and anthropogenic, over land compared to over water. And I'm interested in exploring whether that had a role in the distribution and amounts of precipitation.
Thank you, John.
As we've mentioned, Harvey is still pounding southeast Texas this morning. More than 30 inches of rain has fallen so far, with another 2 feet possible this week. That would bring the total to 50-plus inches from just one storm system. That's the most ever recorded in Texas. Just to give you a sense, if this studio was in the heart of Houston, Texas, 50 inches of water would come up to about right here. That's just over 4 feet. If you think about all the low-lying stuff around your house, 4 feet of water can do catastrophic damage to a home, as we've seen from those heartbreaking images coming out of that region.
When I opened the door, more water rushed in, and all of my stuff flew out, and it just kept coming in. All I could grab was my wallet and my phone. That's all I knew to grab.
Our town was destroyed, and it hurts.
I had to save a guy's life right here. He was hanging onto a telephone pole, and I got a rope. I heard him. He was out there for about 30 minutes.
You just see the water come up, making sure that all our family is safe. We just kept looking at the water, and it just kept getting higher and higher from 4 in the morning to 7 in the morning.
We prayed a lot, and we just praised God, and we were rescued. So we're very thankful.
Yep, there's another way water can get into the air. The water on the doghouse roof dried pretty fast in the warm sun. This water disappears faster because the stove is hotter. This change from water we can see to water vapor we can't see is called evaporation. The cloud from the spout of the tea kettle is condensation of the water vapor from the tea kettle hitting the colder air. The hot water in the kettle gives off water vapor to the air by rapid evaporation, just as rivers, lakes, and ponds give off water vapor to the air by slow evaporation. As the hot water-filled air hits the colder air near the ice tray, the water vapor turns into clouds of tiny water droplets floating in the air, condensation. When the air is quite cold and cannot hold any more water droplets, they collect together to form larger drops, as on the ice tray. And being too heavy to float in the air, they fall back to the earth as rain. Without water in the air, we couldn't live. Our fields would be dry and nothing would grow. The hot water in the kettle gives off water vapor to the air by rapid evaporation, just as rivers, lakes, and ponds give off water vapor to the air by slow evaporation. The hot water in the kettle gives off water vapor to the air by rapid evaporation, just as rivers, lakes, and ponds give off water vapor to the air by slow evaporation. The hot water in the kettle gives off water vapor to the air by rapid evaporation, just as rivers, lakes, and ponds give off water vapor to the air by slow evaporation.
The IT restrictions on everything here. We just got one email where it's saying don't use version of. Well, so exactly, right? So I don't understand why. I wonder.
In the 50s or the 60s, NASA was interested in developing a national program for weather modification. What is there anybody that can talk about the current day program for? You don't know anything about that? Okay.
I would say Google. Google is your friend.
Yeah, I did, and that's how I found out about it. Okay. It was a document, I know, somewhere in there, but does NASA engage in any kind of weather modification today that you know? Oh, okay, so you're not your department. What department are you in?
I'm in a visualization studio.
Yeah, okay.
So we generate these images.
Oh, yeah.
I write software so we can show them up on video.
Cool. Well done.
If you ever wonder where the rain comes from, here it is. This is Lamar County, some kind of power plant. They're using wet surface air coolers, and they're generating clouds like you would not believe. I've just been sitting here on a bike ride, getting all wet. And it's these guys right here that are making the weather. combined with whatever other goddamn crap they're using. Talk about fucked up. Look at this stuff. Goddamn fucking cloud machines. This is where the rain comes from, people. Open your goddamn eyes.
That was actively on social media was the Weather Service. It appeared to be coming from the National Weather Service in the U.S. It was actually coming from San Antonio. So one thing we're going to have to look at is, in an emergency like this, where the local office is knocked out and people need critical information from the federal government, how do we back that up from a distant site? That actually ended up being the biggest challenge. So we'll move on to Maria 10 days later. One remarkable piece of good luck. The NOAA weather radio covering much of Puerto Rico and San Juan is held up. And one commercial radio station that just happened to be the EAS station also held up. So when we issued a flash flood warning for any thunderstorm, we were able to get that out from Miami. It would play on weather radio in Puerto Rico, so if you had a battery operated weather radio, it went off, and also went to the commercial radio station to warn the public. And after about a day, we were verifying the public were hearing our flash flood warnings on their radios in Puerto Rico. So that was really a piece of good luck. And there were a lot of flash flood warnings needed. The threshold was very, very low.
Didn't Doppler radar get taken out in Puerto Rico?
That's actually the very next slide here.
Okay.
That's the Doppler radar. Yeah. So we were not able to do much with warnings when you have it. It's very, very difficult. So what was our lifesaver? Those 16. We were quite fortunate that we were able to get mesoscale sectors over Puerto Rico. So we were getting 1 minute imagery for most of a month following Maria. With that, I'll answer any questions. Thanks.
That was really impressive, and I know people kind of come in and out of the exhibit, but if you didn't catch it, there were three things I saw that were key. So let me ask you this though. I want to ask you a question. That is, so imagine this is a few years from now, and some other major hurricane has gone through a U.S. territory, and you were giving this presentation again, and I kind of want you to fill in the blank here. And you're going to say, well, what we learned from the hurricanes during the 2017 hurricane season, what we learned from the 2017 hurricane season in operations was that we needed to do something, or we learned something, and so we did that this time around. What might that be?
I would say you got to think creatively about the number of things that can go wrong and how they can go wrong and what you might do about it. Because we were doing this on the fly. It's like, oh, how are we going to deal with the lack of radar data? Okay, we've got satellite, but what does that tell you? It's easier to think of that ahead of time and kind of get your game plan together. If you're an individual, think about, well, what if I really am without power for a full month and my road is cut off? How am I going to get information to know that it's safe to be out today in the weather? Or how am I going to have a plan to survive for a month or something? So planning is key. Planning is the key to everything.
Thank you, Kevin. Are there any other Yes, we have a question.
Hey, sorry. Raphael O'Neill, hello, Liberty Beacon climate science investigative journalist and Katrina survivor, so I know all about the preparedness importance and the consequences of severe weather go on for many years afterwards. And you mentioned Doppler radar and taking out Miami, and I actually knew about Harvey before it was a named tropical depression because I have a friend in the military who said he was told to pack his bags. Then I started paying attention to Irma because I have a little PTSD from Katrina, and I noticed it went right into the Doppler radar. Like the eye of the storm went right into Doppler radar. And then I wondered if it was going to keep on doing that. And sure enough, for two others, it went right into Doppler radar. And then Nate, New Orleans was next, and it was coming right for KLIX and Slidell. And then it was sucked from there to the next one, and then to the next one. Then we looked at Katrina, and that was 5 Doppler radars in a row. The hurricanes hopped from one to the other, including the same one in Irma, Puerto Rico. Its Doppler radar had the eye coming right for it. Short of the patents that we found that could actually legitimize the technology that, the weaponization of that, is there any chances that there's inadvertent attraction, like weather modification going on from just the stimulating of the atmosphere and trying to read the weather? I mean, because we also saw that, I heard, I don't know if this is official, but from my military source, that there was a damage to the Doppler in Houston. It bounced around between 3 Dopplers there. This is concerning, and we would like some answers, and we can't get meteorologists to really answer the questions, so if you have any answers.
So one thing we were lucky with Harvey is the Corpus Christi radar was missed by about 70 to 80 miles, and Houston radar was missed by 40 miles or so. So those stayed up and running, so we were lucky about that. Key West radar, right there, the red dots, at this point the eye was moving north and moved about right there. So missed it by about 20 miles, and we actually got quite lucky with that.
Okay, because that's not what
that allowed the radar to stay up.
Because I saw the capture, the capture from the news source showed it going right into it, and that's what I got on my video.
Yeah, this one missed by, it actually drove down there. The worst damage was about right there. And we're lucky with that because Key West radar was missed by about 10 to 20 miles from the worst damage. So
they're still significantly close, relatively. They're not going miles between them. They're going within in that direction.
Thought of what the radar network was in the early 90s, was in the planning stage, and there was a lot of attention paid to putting mini radars on the coast so we could see out far to see hurricanes and get better information. So there's probably a lot of perception over the years that the hurricanes may head right toward the radars, but that's because there's a lot of them now. And there's actually the FAA radars. We have 3 of them in the Miami area. There's 2 in the Houston area, I think.
3 Doppler radars in Miami? Where do you get that from? Not according to the NOAA. And that's not what we're seeing. We're not seeing it going into some other radar. We're seeing it going into KBYX, then went into KYBW, and then KJAX. And we even saw the laser beams going into it. So they're not that close to each other. There's plenty of room for the eye to go here or here or here. It went in here.
Because we got a team researching how many hurricanes are doing this, because it's going in a line. Like if you're playing pool, you know how to kind of line it. Even if it kind of missed, you didn't line it over there or between these two, you're going in that direction, and that's what we're seeing. And then we're seeing it get pulled in the other direction, and it's very alarming.
And in this case, of course, this was moving due north, so I would say that it didn't move toward the radar, it moved by the radar. That's my thought. Any other questions, any folks?
Thank you. I appreciate it.
Good. So I guess we're doing right.
Okay, thank you very much, Kevin. Let's hear for Kevin Scharfenberg.
Okay, so he said some of the worst damage was done on this part of the island, and that's proof that it didn't come right for the Doppler radar. Anyone who's actually lived in a hurricane area knows that the east side is the side that gets the dump of water. It's the worst weather. We had that happen. That's why Slidell got the worst of it. New Orleans got the better of Katrina. So his explanation is completely bogus. Here is the eye. Here is the eye, and here it is going. Watch.
The American landfall of this hurricane is imminent. It will happen in the lower Florida Keys, more likely not in Key West, but another one of the...
Good morning. My name is Yaga Richter from NCAR, and I'm going to talk to you about building confidence and reducing risk with strategic geoengineering. Yep. The reason we think this would work, because the natural analog is volcanoes. So when you have a large volcanic eruption, a large part of what comes out of volcanoes is sulfur dioxide, or SO2, and it gets injected into the stratosphere, and through this stratospheric circulation starts covering the planet, kind of like a little blanket, and part of the radiation is reflected, and we observe cooling for about 2 to 5 years after a major volcanic eruption. And before I begin any further, everything that I'm going to talk about here has been done in a modeling framework, so everything I say here refers to model. None of this is actually happening in the real world. I thought I should make the disclaimer as for some newer people in the audience that may not be clear. Anyway, so the earlier approaches in modeling frameworks have been to either dim the sun, prescribe aerosols, or inject SO2 directly into the stratosphere and then examine the impact. And all of these studies demonstrated the ability to counteract global mean temperature, which is already huge progress. However, there have been many unintended side effects and risks that have come along with that strategy. The main ones being overcooling in the tropics, warmer temperatures in high latitudes, reduced precipitation, shifts in rain patterns, and Arctic sea ice still melting since you're still warmer than you want to be in the polar regions. So what we are doing is we're calling here strategic geoengineering. Rather than starting with prescribing the injections or prescribing the aerosol concentrations, we start with the climate goals that we would like to achieve. Then we design a strategy to meet the goals, and then we go examine the remaining side effects, with the idea that we would continue this process once we know what the remaining side effects are. We would try to make those the goal and try to alleviate them. So far, we've only gotten to this first half of the process. As the research goes on, hopefully, we'll be making the circle around more than one time. Okay, time to wrap up. So I left the slide, so I can skip it out. So in short, strategic geoengineering with stratospheric aerosols in simulations with CS and WACM reduces several of the side effects of geoengineering, and I'm only talking about the physical system here. And regional changes still exist and need to be evaluated further. And we would love to have you help us evaluate the benefits and side effects and work with this large ensemble project. We're starting to have about monthly telecons with the people who are interested. We're an easygoing group, so I invite you to get in touch with us. Thank you.
Thank you, Yoga. Interesting opportunities there. We'll take one question every.
Okay, quick comment and a question. I'm glad to see that you're looking at gradients, but if you're concerned about the water cycle, the land to ocean temperature gradient is extremely important. I know that's much more difficult in zonal winds. The comment is that the question is this: for the troposphere, where we have vastly more measurements and we have vastly greater understanding of the processes, the CMIP models, and there are about 30 of them, give us a range of answers about how the temperature would behave. If you take the mean of them all, then it kind of looks like, but there's a lot of variability in those models. How much confidence do you actually build when you run one model, maybe a bunch of times, but it's just one model for the stratosphere, for which we have so much less information about everything, about the dynamics, about the thermodynamics, about the physics of aerosols in the stratosphere, and so on?
So that's a great question, and we are waiting for the next model that has the same capability as ours, and the minute the model is ready, we want to run the same simulations with that model. So right now, we don't have another model that we can run with. So I think some of the European models are close, but they either have the interactive chemistry, but not the interactive ocean, or they have interactive aerosols, but not enough chemistry. There is not a model that we think that we can do this immediately. There's intermediate steps, but we cannot do the fully interactive process in any existing other model.
Models would increase the confidence?
You would need to have all the CMIP models. The more models, the more confidence, right? So, but at least
Well, what about measurements?
Measurements of.
I think we need to move on now to our next talk.
Great question.
So our next speaker is Alan Robach on stratospheric geoengineering risks and benefits.
Thanks. Dave asked me to give sort of an overview of geoengineering. So I'm going to, here's our situation. We want to be happy, so we have stuff, and stuff uses energy, and a lot of energy produces CO2, which a lot of it stays in the atmosphere, which causes climate change, which has impacts, which has a negative feedback on our desire to be happy.
Over 26 billion tons. For each American, it's about 20 tons. For people in poor countries, it's less than 1 ton. It's an average about 5 tons for everyone on the planet. And somehow we have to make changes that will bring that down to 0. It's been constantly going up. It's only various economic changes that have even flattened it at all. So we have to go from rapidly rising to falling and falling all the way to zero. This equation has four factors, a little bit of multiplication. So you've got a thing on the left, CO2, that you want to get to zero, and that's going to be based on the number of people, the services each person's using on average, the energy on average for each service, and the CO2 being put out per unit of energy. So let's look at each one of these and see how we can get this down to zero. Probably one of these numbers is going to have to get pretty near to zero. That's back from high school algebra. But let's take a look. First, we've got population. The world today has 6.8 billion people. That's headed up to about 9 billion. Now, if we do a really great job on new vaccines, health care, reproductive health services, we could lower that by perhaps 10 or 15%. But there we see an increase of about 1.3. The second factor is the services we use. This encompasses everything: the food we eat, clothing, TV, heating. These are very good things. Getting rid of poverty means providing these services to almost everyone on the planet. And it's a great thing for this number to go up. In the rich world, perhaps the top 1 billion, we probably could cut back and use less. But every year, this number on average is going to go up.
So how do we break this loop? Well, we can do green things like conservation or efficiency or low carbon energy. But if those don't work, then people have suggested maybe taking the CO2 out of the atmosphere or doing solar radiation management. And absent that, we have adaptation. Absent that, we have suffering. So these blue things are called geoengineering. And unfortunately, the term or climate intervention is applied to both of them, but they're quite different. This one is treating the illness, and this one is treating the symptoms. So the first one, taking CO2 out, is probably a good thing. I'm not going to talk about that. I'm going to talk about this idea. So just one slide. This is the problem we're facing. This is the climate change we have in the future, these colored lines compared to climate change of the past 1,500 years. It's going to be huge, even with some mitigation. That's why we're concerned. I gave the first talk on geoengineering at an AMS meeting 10 years ago at the meeting in New Orleans. And people were kind of in shock. You're thinking about this? And I'm surprised 10 years later how much interest there still is, unfortunately, because we haven't solved the problem. So what is geoengineering? It's defined as deliberate, large-scale manipulation of the planetary environment to counteract anthropogenic climate change. So it has to be deliberate, it has to be a large scale, and it's not driving your car and emitting CO2. That's not geoengineering, because your idea was not to cause climate change. The U.S. National Academy of Sciences published a report 2 years ago, and I presented it at the AAAS meeting in San Jose, and that began a project to look at the impacts on ecosystems, which I'll tell you about in a minute. They said these two things are different, so they wrote two different books, one on carbon dioxide removal, one on solar radiation management. Why did they call it climate intervention? They said if we call it engineering, it makes it sound like we know what we're doing, we're in control. So we want to call it intervention, which is an action to try and have an impact, but we're not sure what it is. This is really geoengineering. The ideas for solar radiation management include space-based reflectors, creating a cloud in the stratosphere, brightening clouds in the troposphere, or brightening the surface. And I'm going to focus just on stratospheric aerosols, which is the idea that's gotten the most attention, which is what Yaga talked about also. So I went to the first meeting on geoengineering at NASA Ames, and this issue of Rolling Stone came out that week, and across the top, it's got our two favorite people there, but across the top, Dr. Evil's plan to stop global warming. And inside there was an article about Lowell Wood, who used to work with Edward Teller, saying, oh, we can control the climate. I'm a physicist, I'm smart, I know what to do. And I went to this meeting for 2 days at NASA Ames, and the room was too hot, and they couldn't control the temperature of the room, but they were talking about controlling the temperature of the planet. And there was these physicists and engineers thought, oh, this is a really cool problem. And I started writing down reasons why I thought maybe it wasn't such a good idea. And I got up to 20, and I published a paper, 20 reasons why geoengineering may be a bad idea. And since then, I've looked at it more, and my latest paper has this list of 27 reasons for concern or risks.
but it also has benefits. Like if we could do it, we could reduce global warming, number one, and that benefit might be worth dealing with all of these risks. But I think we have to evaluate each of them so that we can then make informed decisions in the future. Now, how do you test these things with the real world? You can use volcanoes as an analog, as Yaga mentioned. So these are the things that you can test with the volcanic analog. And so, for example, you get beautiful sunsets. This is after Krakatoa. This is the volcanic sunset from Monk, and this is a picture I took over Lake Mendota. But volcanic eruptions warn us that volcanoes could cool, stratospheric aerosols could cool the surface, reduce ice melt and sea level rise, produce pretty sunsets, increase the CO2 sink, but reduce summer monsoon precipitation, destroy ozone, produce rapid warming when stopped, make the sky white, reduce solar power, perturb the ecology, damage airplanes, and so forth. Some people say geoengineering is cheap and easy, and it turns out that we don't know how to do it. There's no equipment right now to do it, and it might be very expensive.
The little picture is from a nanofabrication study, which shows you can make very high quality, and do this in just a jet in a very simple way, make high quality alumina particles just by spraying aluminum vapor out, which oxidizes. So it's certainly in principle possible to do that. There's a big literature that's already looked at that. And you could do that by either building new versions of these aircraft or even re-engineering existing aircraft. So there's some ideas of that. So you go to an engineering firm and you want this done. They don't say this is hard or unusual. They say, okay, yes, we could do it. Aerosol geoengineering looks like it is so cheap that the cost is basically not going to be an issue. That means that implementation decisions will be risk-to-risk decisions. The risk of doing it against the risk of not doing it. And it makes the problem of how we govern it fundamentally harder and different and novel. So I've told you that it's cheap to deliver materials to the stratosphere, and I'm convinced that's true. I don't think that will change. But I think the more we do research, the less easy this will look, the more complicated the environmental effects will look. And that's a good thing, because right now it looks too easy. So I think that if we do more research, we're likely to find out that it's harder and more complicated than we thought, and that the side effects are harder to manage, and that's a healthy outcome that will make it easier to do the management. Of course, the opposite reaction is possible. It's an empirical question, how people will actually react to knowledge about this. Another reaction is to say, if these crazy scientists are so concerned about putting CO2 in the atmosphere, they want to think about these things, then that might actually mean we should be more serious about the risks of CO2 in the atmosphere. And by the way, it's not really a moral hazard. It's more like free riding on our grandkids. And by the way, it's not really a moral hazard. It's more like free riding on our grandkids.
So not only does David Keith educate us on the ease of geoengineering and the low cost of geoengineering, but his concerns that this low cost and ease would make governance an issue. As many people would be scampering to use this technology, it would make it harder to do the magic, quote unquote.
Some people say geoengineering is cheap and easy, and it turns out that we don't know how to do it. There's no equipment right now to do it, and it might be very expensive. But Niemeyer and Timrak did this experiment balancing RCP 8.5 with geoengineering, and they got 5 to 7 Pinatubos per year, not 4, by the end of the century if they wanted to balance this. That would be a huge amount. So I encourage you to read all the 6 recommendations of this report, which I don't have time to go over. But I just wanted to point out that a lot of the things on my list are not testable with modeling or volcanic analog. Things like human error, unexpected consequences, commercial control, how do you decide whose hand's on the thermostat? And so I don't think it's ever going to happen because of these insoluble problems. If we ever do it, we might want to shave off the worst climate change. But would it make it more dangerous if we did it? Thanks.
Time for one question.
Raphael O'Neill, Liberty Beacon, investigative journalist for climate science and engineering. Yesterday, outside of the ACS, there was jet cirrus on an otherwise blue sky day. I watched it unfold in the morning and then throughout the day. So I know that's not stratospheric, that's tropospheric, but the Smithsonian Institute said that jet airplane contrails could be doing inadvertent geoengineering. And so we're seeing a lot of that. But we've been complaining about dimming skies increasingly, and we're laughed at if we use the wrong terminology, even though contrails don't form on pixie dust. So what are we really hoping is going to be accomplished by doing more of that higher up, throwing more chemicals at the problem instead of, say, like finding another way besides releasing 70% of our energy as heat waste in power plants and using microwave heaters and ionospheric heaters?
So Dave's going to talk about cirrus thinning as an idea, another idea to let more heat out. There is no if you're asking the chemtrails question, are we actually trying to control it outdoors now?
I'm not talking about deliberate, but even inadvertent, we're doing it. And I know engine performance factors have changed, allowing for more contrail
The last IPCC
formation.
report looked at the impact on climate change of contrails, and it's really tiny.
Well, not according to us, who have been losing our suns and our skies.
Well,
and
you have to look at the data and the
And we're
science.
seeing our rain coming out of power plants, flooding New Orleans and Louisiana and every place. Well, we're seeing that, so we have it on radar.
I think we need to move on.
Okay, well, please consider the other options because we don't approve. Stop spraying us.
Next speaker is Deborah Weinstein.
Deliberately or accidentally is unacceptable. And you all know it.
Talking about geoengineering beyond SO2.
Yeah. A bunch of bull, really.
Point 1. Cirrus thinning. Cirrus cloud thinning is a proposed form of climate engineering. Cirrus clouds are high, cold ice that, like other clouds, both reflect sunlight and absorb warming infrared radiation. However, they differ from other types of clouds in that, on average, infrared absorption outweighs sunlight reflection, resulting in a net warming effect on the climate. Therefore, thinning or removing these clouds would reduce their heat-trapping capacity, resulting in a cooling effect on Earth's climate. This could be a potential tool to reduce anthropogenic global warming. Cirrus cloud thinning is an alternative category of climate engineering in addition to solar radiation management and greenhouse gas removal. Wow. Indeed, it is a studied concept. Subsaturated environment. In the past decade, ice supersaturated regions in the upper troposphere were a focus of atmospheric research. These regions cover large parts of the tropopause region. They are potential formation regions for cirrus clouds since ice formation needs a certain ice supersaturation. In addition, contrails, i.e. ice clouds formed directly by anthropogenic injections, can appear and evolve to aviation-induced cirrus in supersaturated air. Both cirrus and contrails are known to impact the Earth's climate. Let's repeat this. Both cirrus and contrails are known to impact the Earth's climate. 2007, Burkhardt 2010, but estimates of this impact are still deficient. To improve the estimates requires advanced knowledge of cirrus and contrail ice microphysics and radiative properties, as well as the global distribution of upper tropospheric ice supersaturation. So here they performed an experiment. And here's a aircraft vapor trail control system to help you achieve that. An aircraft propulsion control system for an aircraft having a plurality of combustion engines is provided. The system has a plurality of sensors for sensing a condition indicative of properties and or formation of vapor trails, which may be formed by the plurality of engines. A controller is arranged to control one or more operational variables for each of the plurality of engines. The controller is arranged to undertake a search of trial values of the operational variable by instructing different concurrent values of said operational variables across the plurality of engines and determining the resulting impact on the vapor trail formation and or properties as sensed by the sensors. A population-based search may be performed, for example, in parallel over all the engines at once so as to reduce the time taken to achieve vapor trail mitigation. So there are systems, patents in place to resolve this problem. This one is 2014. Point 2. The IPCC says contrails' impact on climate change is tiny. But the IPCC continues with its talking points, using, of course, ridicule to make its point somehow. Solar radiation powers of the climate system. Greenhouse gases led by CO2 are leading contributors to climate change drivers. Okay, this is just to document what comes up. IPCC greenhouse gases. The first ones are the ones with CO2. Does this show greenhouse gas emissions by sector? CO2 from fossil fuel. Where's the water? Where's H2O, which is 80 to 90% of the greenhouse gases? Okay. CO2 from fossil fuel. Shares of global anthropogenic GHG emissions. Why are contrails not on here? I promise I'm not making it up. Water vapor is... I've got to find a graph here that talks about water vapor. Carbon dioxide. I mean, this is just Google Images, so this is showing me all the articles that would... Carbon dioxide is the big bulk here. Am I a liar? I must be a liar. I mean, how can the largest carbon dioxide... All these maps are showing carbon dioxide as the most prominent carbon dioxide. Wow. And yet, we're just going to change this. Let's add water vapor. If you look for it, they can't hide it from you because it is a scientific fact. Oh yeah, here we go. Water vapor. CO2, other. See that? Water vapor. It's there. I didn't make it up. It's a scientific fact. And yet, did we see that anywhere when we Googled greenhouse gases IPCC? Here, look. Where's that water vapor chart? There, no, no. That's CO2 from fossil fuel. I mean, I'm not an apologist, okay? Stop right there. I'm not an apologist for industry. I didn't like the BP oil spill and the corrects that they used afterwards to clean up in the Gulf, and I don't eat fish from my region anymore. Okay? But how do we go from that to IPCC greenhouse? Where is water? Where is water? Water isn't anywhere. Do you know how they scour and control the Google searches more than ever. They are deciding for you what is real and what is fake news, and yet the most basic scientific fact is being kept from you. U.S. greenhouse gas emissions 2014. What about all that just water vapor? It's just water vapor. It's just water vapor we saw landing in Louisiana out of the power plants that synchronized their releases to feed into the storm. It's just water vapor we see coming out of clouds, and yet NASA says even small changes in the abundance or location of clouds could change the climate more than the anticipated changes caused by greenhouse gases. It is a greenhouse gas. Human-produced aerosols or other factors associated with global change. Let's see what the rest of the world is saying. This was all in 2007. Radiative forcing due to clouds and water vapor. This means clouds matter. Radiative forcing. For the greenhouse effect, clouds, water vapor, and CO2 are of the utmost importance. A Harvard study NASA, ADS, Physics and Abstract Service, probabilistic description of ice supersaturated layers and low-resolution profiles of relative humidity. The global observation, assimilation, and prediction in numerical models of ice supersaturated regions are crucial if the climate impact of aircraft condensation trails is to be fully understood, and if, for example, contrail formation is to be avoided through aircraft operational measures. A robust assessment of the global distribution of ISSR will further this debate, and ISS event occurrence, frequency, and spatial scales have recently attracted significant attention. This will be useful in understanding and improving the global distribution, both observed and forecasted, of ice supersaturation, which leads to contrail formation. That is the number one factor in determining whether a contrail will persist, apparently, besides, obviously, employing a cocktail that could do as such. The IPCC does have a changes in atmospheric constituents and in radiated forcing detailed paper here, page 152. We've got advances in modeling the aerosol direct effect, stratospheric water vapor, radiative forcing by anthropogenic surface, albedo change, black carbon in snow and ice, tropospheric water vapor from anthropogenic sources, anthropogenic heat releases. Well, we're going to check that out. Page 152. The TAR noted that several studies had indicated long-term increases in stratospheric water vapor and acknowledged that these trends would contribute to a significant radiative impact. However, it only considered the stratospheric water vapor increase expected from CH4 increases as an RF, and this was estimated to contribute 2 to 5% of the total CH4 RF. This section 3.4 discusses the evidence for stratospheric water vapor trends and present the current understanding of their possible causes. There are now 14 years of global stratospheric water vapor from halogen occultation experiment and contributed balloon-based measurements since 1980 at Boulder, Colorado. There is some evidence of a sustained long-term increase in stratospheric water vapor of around 0.05 parts per million a year, -1, from 1980 until roughly 2000. Since then, water vapor concentrations in the lower stratosphere have been decreasing. So what we have is a decrease in water vapor on ground level and an increasing of water vapor in the higher levels of atmosphere, which is also why these changing atmospheric conditions yield to more persisting contrails. But aviation, let's continue here. Aerosols are known to have a drying effect. Here, see aerosols and weather. In nature, aerosols, dust and smoke, and weather interact in an intricate fashion. A long, dry weather pattern or drought can lead to forest fires and dust storms, while in the atmosphere, the smoke and dust disturb incoming sunlight and may cause a cooling of the Earth's surface. Conversely, the aerosols may trap long-wave energy and cause surface warming and a continuation of drought. Thus, our long-term weather or climate could change if large quantities of aerosols remained in our atmosphere for extended periods of time. We have that just with pollution. Here is a review of secondary organic aerosol formation from isoprene. It is showing that pollution has an effect on climate. You okay, Pepper? Atmospheric fine particles are linked to adverse health effects, visibility reduction, and climate change. Okay? Period. So why are we going to ignore airplane contrails? Or worse than CO2 emissions for global warming, according to a study. This is in physics.org. NASA, cirrus cloud and climate modifications due to subsonic aircraft exhaust. This is not a great big mystery. So there's nothing new here. Human impact on direct and diffuse solar radiation during the industrial era. Anthropogenic aerosols inhibit cloud formation. In the study, the direct and diffuse solar radiation changes are estimated, and they contribute to the understanding of the observed global dimming and the more recent global brightening during the industrial era. Using a multi-stream radiative transfer model, the authors calculate the impacts of changes in ozone, NO2, water vapor, CH4, CO2, direct and indirect aerosol effects, contrails, and aviation-induced cirrus on solar irradiances at the surface. Simulating aerosols and their feedback effects on temperatures in a polluted urban environment. Here's a 1987 contrail study. Urban aerosols are important because they directly and indirectly affect air quality and local meteorology in several ways. For example, submicron-sized aerosols affect human health by directly penetrating to the deepest part of human lungs. In addition, particles serve as sites on which chemical reactions take place and as sinks in which some gas phase species are removed. Further, particles that are between 0.2 and 1 UMs in diameters and contain sulfate, nitrate, and organic carbon scatter light efficiently, while those that are smaller than 1 and contain elemental carbon absorb efficiently. The absorption and scattering properties of aerosols are significant because they affect surface air temperatures. Some of the first studies of the impacts of aerosols on surface air temperatures resulted in the following conclusions. First, aerosols backscatter a fraction of solar radiation, tending to reduce surface air temperatures during the day. Second, some aerosols absorb solar radiation, decreasing the effect of cooling caused by backscattering. Third, many aerosols absorb and re-emit the Earth's infrared radiation, or Doppler radar's microwave radiation, causing surface air to warm or nuke, especially at night. More recent studies on a global scale have supported the contention that aerosols backscatter shortwave radiation, thereby decreasing surface temperatures. Finally, some studies have found that aerosols, which serve as cloud condensation nuclei, indirectly affect temperature by altering the size distribution of cloud droplets, thereby changing cloud albedo. The net effect of aerosols on surface air temperature varies significantly from location to location because particle composition varies significantly from location to location. For example, coastal urban aerosols are influenced by emissions of elemental carbon, organic carbon, metals from the road dust, and sodium and chloride from sea spray. In addition, gas to particle conversion in urban produces secondary organic carbon, sulfate, nitrate, and ammonium. Free tropospheric aerosols, on the other hand, are dominated by the presence of sulfate. By the way, catalytic converters in cars are creating a nanoparticulate nightmare, cancer-causing, ground-level disaster event that is being blocked out by media as well. Never mind what is going on the tropospheric and stratospheric levels. We're in trouble at every level. But staying focused on climate engineering, we just wanted to show that pollutions and aerosols do affect climate, and so do, of course, contrails, as aviation pollution, whether it's deliberate or accidental, unintended consequences of atmospheric injection of sulfate aerosols. Here they say it's an inexpensive fix. Here they're telling you how to minimize the risks by targeting research, direct radiative forcing, and climate effects of anthropogenic aerosols with different mixing states over China. Aerosols, direct radiative forcing equals pollution and decreased rain. An online coupled regional climate and chemistry model was used to investigate the direct effects of anthropogenic aerosols, sulfate, nitrate, black carbon, and organic carbon with different mixing states over China. Both aerosol direct radiative forcing and corresponding climate responses were sensitive to aerosol mixing states and BCOC hygroscopicities. Okay. Aviation Climate Change Research Initiative, a report on the way forward on review of research. Contrails and induced cirrus. Page 20 shows that this adds water vapor. Here we go. Contrails and induced cirrus optics and radiation. Due to substantial increases in air traffic over the globe, soot particles, composed mainly of black carbon along with sulfur compounds and water vapor, have infiltrated the upper atmosphere, causing increased frequency in the occurrence of contrails and contrail-induced cirrus clouds. There's an upward trend of cirrus cloud cover over the past 50 years near U.S. flight corridors, and that this increase corresponds to the rising trend of jet fuel consumption. Although the coverage of contrails and contrail cirrus clouds is much less than that of a naturally forming cirrus clouds, their radiative effects are not negligible, particularly near flight corridors, where they are frequently observed. Okay, so here the thermodynamic conditions for contrail formations can be incorporated in large-scale models. Initially, the aircraft's water vapor is rapidly converted to ice as ice crystals are nucleated and environmental humidity is taken up. These ice crystals are quickly captured and transported downward by the vortex pair generated by the aircraft. Whether contrails shrink and disappear or develop into contrail cirrus is dependent upon the environmental relative humidity with respect to ice. In an ice supersaturated atmosphere, contrails persist. Contrail crystals develop and extract excess environmental water vapor. Optical and microphysical properties of contrails differ from those of natural cirrus, but with age they may become similar. The transition of line-shaped contrails into cirrus-like clouds, however, is not well understood nor well represented in climate models. To date, only a few field campaigns, including Success and Sulfur 1 through 7, have been devoted to in situ measurements of the macrophysical and chemical properties of contrails and contrail cirrus clouds. Wow. As much as it's a major part of the climate cycle, not much has been done to study this. Oh, no. As a result, the current understanding of contrail properties as well as the aerosol indirect effects associated with aircraft emissions is still extremely limited. Statistical analysis of contrail to cirrus evolution during the contrail and cirrus experiments, CONCERT. This was 2017, air traffic effects of the cloudiness and thus the climate by emitting exhaust gases and particles. The study of the evolution of contrail properties is very challenging due to the complex integrity of vortex dynamics and atmospheric environment, temperatures, and supersaturation. In this study, various contrail cases corresponding to the different aircraft types and atmospheric conditions are investigated using a statistical method based on the in situ optical measurements performed during the CONCERT campaigns 2008 and 11. Study on air traffic effects on climate. Dehydration effects from contrails in a coupled contrail climate model. So we have a drier ground floor. We have more humidity up in the upper troposphere than we do on the lower troposphere. Something is drying down below and humidity is being inserted at a higher level, but it's drying, it's dropping the aerosols more and having a dry, just this cycle of drought. Drought for the Northwest. Although snowpack levels throughout the West are average or better this year. Cloud seeding. The Northwest faces another year of drought. Well, 1994.
I was trained adjunct Air Force by the National Weather Service. Now, the technology that we used was 40 years ahead of anything that was sitting in people's homes. And that's par for the course with the military. In 1983, they had just kicked into gear full weather manipulation. And I was in the military at that time as a weather forecaster.
Full weather model.
And it was, the facade was to help farmers in times of drought. And that's what they patented under, was relief to drought and famine situations, when the reverse is actually to create famine and drought situation.
Right.
At each stratum of the atmosphere, which could be 1,000 feet, 5,000 feet, 500 feet. It all depends on what stratum they're looking at. All right? It's very inexact science, believe me. We did not have the red phone to God. The only place that you can predict the possibility of humidity is at base level, which is usually from 0 to 4,000 feet in the air. And that is with 20% accuracy rate.
Okay. So these are not readings from balloons that get an actual...
No, you can't get relative humidity from a balloon. I never did. We never did.
Okay. And is there any chance that the technology might have changed since?
Yes.
When were you in the Air Force?
I don't understand the new formulas. They don't make any sense to me.
When were you in the Air Force?
1979 to 1985.
Okay. So you know when they started in 1983. Were you aware of it? Yeah, because you were part of the weather, for food.
Yes, weather for food, yeah.
And it created drought and famine instead of relieved it. And those were complaints that were going on for a while, actually, because that was in the Senate committee hearing, one of the complaints they listed in 1970. So this is not a new story. And the World Meteorological Organization admitted in their own report, even though they said there was no weather modification going on in the United States, in the same report later on, in a timeline thing, they credit hydrological companies having been some of the players that have been at it the longest in the States for 50 years ongoing. So if there's a program going on for 50 years ongoing, then how can we say there's no weather modification going on in the States? Why is that not being cataloged and reported? And that didn't even include all the military experiments, and we know that the military's not going to just... The largest industrial military complex is just not going to just all of a sudden sit on its hands about it when they've been doing it since the beginning of time. So there's no way really to monitor the humidity. And you are also saying it's not possible to have humidity that much, more humidity on the upper atmosphere than on the lower atmosphere?
No, it's not possible. Because the farther up you get, the less air there is.
And
so condensation nuclei, which is exactly what it's dust particles, it's anything that a water molecule can attach to in order to form a cloud. And I'm going to tell you something. None of the clouds that I see on a daily basis are anything like clouds. They're all fake clouds.
Yeah.
Can't even find the bases on a stratus level. They all have this icky goo that comes out from the bottom of every single freaking cloud. I can't tell you where the bases are of a cirrus. I don't know what level. Like right now, I'm looking outside, and I'm trying to determine the base level, which would be my report, as in 5 scattered, meaning 5,000 scattered, 5,000 feet in elevation, scattered. I can't find a bottom. I can't find a base, and I can't do it with altitude. I can't find the bases of the clouds anymore. I'm guessing, and my scientific guess is pretty freaking good. But right now, I'm looking out here in this ugly muck that we live in every day. I see one cloud with a base, but they're not consistent. And then I'm farther away, and there's no, a base of the cloud is darker. It's the dark point where it sits at the elevation, which allows you to determine its height from the ground. Okay? And right now, if I was to look out there, which I'm doing, I have one cloud that I see one base on, but it has all this goo hanging from it. And that is the trigger. It's all goo. There's no bases. So I'm guessing that I've got a 5,000-foot overcast sky. But I don't know for sure because I can't find a base.
Point 3. We're talking about geoengineering beyond SO2. What are contrails? Carbon dioxide, water vapor, nitric oxides, sulfur dioxide. So yeah, a contrail, is beyond SO2, right? Because we got sulfur dioxide, we got water vapor, and we showed how significant water vapor is to the equation. Nitric oxides, well, that's important. And you're telling me carbon dioxide is important. So is there a reason why you continue to ignore aviation emissions in your problem area or undermine the significance of it? It's not just SO2. We're not just talking about SO2 because we're also talking about chemical cocktails that we don't know what there is. We don't know. There's no one who feels obligated to answer to us. There's no one who feels obligated to answer to their own science. Also, we're not just talking about SO2 because we're talking about albedo modification, which has a value completely different from whatever other value there is to water vapor alone. Because clouds, once condensed, have reflective properties called albedo, and they modify the heat balances and exchanges between the Earth's surface and space. This is significant. This is not to be dismissed. This is what they want to do with stratospheric aerosol geoengineering. This is what the contrails are doing. Maybe a little too well because now they have to discuss cirrus thinning. Aviation.stackexchange.com. Do jet contrails impact weather on the ground? This one got the best votes. Based on past observations and a study led by Patrick Minnis from NASA, contrails could result in increasing the temperatures over the ground by 1 degree Celsius every 30 years over the U.S. From a study by German researchers like Ulrich Burkhardt and Bernhard Kocher, the effect of contrails is comparable in other areas with a similar level of air traffic. Because the air traffic is said to be about to increase very quickly, the effects of contrails on the temperature may increase too. Contrails are like cirrus, and actually some just become persistent cirrus. Sometimes it's difficult to tell which one is a condensation trail, which one is a natural cloud. This makes more difficult the study of contrail effects and introduces many uncertainties that need to be reduced. Actually, I find it very easy to tell which ones are from the planes. They fan out, they connect, where you know they would not be. Sometimes it's hard, but generally it's pretty clear, unlike the skies. Massive amount of cloud creation.
small changes in the location and abundance of clouds can alter the weather more than greenhouse gases and other factors attributed with global change. NASA. What you gonna do about that?
The whole thing is a big cone that comes out of that plane right there.
Yeah, coming out of that factory.
It's hard to believe, but there it is. You can't deny it. That thing is directly over that power plant.
Power plants and other industry. What kind of industry is that?
Chemical industry.
Chemical industry. Creating climate change. CO2 ain't that big a deal. Clouds, my friends. Clouds. Pay attention to them. Soot and aerosols, too.
6:13 p.m.
6:13 p.m. on the 5th of September.
We might want to find out which way the wind is blowing.
Well,
because if it is blowing that way,
we see some clouds over there, too. They're following low along the... I mean, but I've seen this. It's not even like a secret. It's just like hiding in plain sight. It's just hiding in plain sight.
Well, I've never seen anything that big. I've seen clouds that sort of form over a power plant and they sort of wisp away, but I've never seen anything as big.
Maybe they're adding something to the cocktail. Maybe that's what's just coming out.
Never seen it.
Accumulating water vapor creates clouds. Just like a kettle boils and creates vapor, evaporation happens in nature as well. Condensation, clouds, rain. There are approximately 7,000 power plants in the U.S. Almost all of which have large cooling towers or banks of WSAC, wet surface air coolers, each of which can produce thousands of gallons of water vapor per minute. Open loop, closed loop, WSAC. Steam is cooled in cooling towers. Generator makes electricity. Water is turned to steam in the boiler. Sequential water vapor cloud fueling. First toot gets you a moderate sized cloud, then a bigger one on the second toot, third one, bigger, until you get a nice billowing smoke. Here are some of the power plants at the beginning of this continent's water vapor generation cycle in Texas and Mexico. Nice round cooling systems. Let's look at these 3 power plants, for example. See the same circular systems. It is these cooling systems releases that are feeding the water vapor. Fair use notice for educational and environmental activism purposes. Credit to Disney for Zootopia. Now watch how the propaganda works to normalize weather modification, including power plants with synchronized release for maximum water vapor creation. Bunny's on her way to Zootopia, where a bunny can be anything the bunny wants to be. She's going through fair climate. See the steam coming out of the wall powered by what looks like power plants? Train goes through a winter wonderland all of a sudden, powered by these synchronized water vapor releases that look like they're coming out of these circular vents. The whole winter wonderland world is ice frozen over artificially. In the perfected future, all animals live as one and all climates will be manageable. Now she's in a tropic, also assisted by man, as the song Try Everything plays. Try everything. And going back to our power plants and water vapor release, synchronized. Gone. Gone are the days I can listen to the rain falling down outside my window pane and not think it is some enemy trying to wash us away. Gone. I wrote that in the weeks and days after my return to New Orleans, after my hurrication from Katrina in New Orleans, which I had left the Tuesday after the storm.
All right, we are here with my guest, who shall be remain. Well, how may we refer to you?
I'm going to remain as much as an open book as possible, but to protect myself and my family. Captain G.
Captain G.
Of the 104th Transportation Division.
Okay, of the 104th Transportation Division. Rank at discharge.
Was a captain.
And branch of Army component active.
That's correct, 14 years.
Okay, POB.
Aberdeen Proving Grounds. That's where we test missiles.
Aberdeen, Maryland.
Yes, at that time, that's where my father was stationed.
Okay, and your time of discharge was medical.
Right, because during my second tour during Iraq, while in a sandstorm, I was ambushed, and for this great country that I thought believed in me, I took 5 bullets for, but as strange as it sounds, I would probably take another 5.
That's beautiful, and thank you for that. And you had deliveries too. What about some of the harder things you delivered?
Well, in 2005, New Orleans was struck by what they call Hurricane Katrina. And at that time, I was stationed in a military base in Georgia. And I found it strange, but 11 days before the storm hit, 11 days, I mean, I don't even think I remember hearing anything being predicted about this storm coming until about 4 or 5 days before the storm. But this emergency conference came in for us to gather up as many body bags. You're going to need about 5,200 body bags. First thing I'm thinking is, oh, fuck. The Iraqis have taken over, there's some big terrorist event that's about to go down on us. And basically, I was correct, but it wasn't See, my mind was be trained to think that the Arabs, the Muslims, were our terrorists, but today, that particular day, the United States government was the biggest fucking terrorist. And I say this to say I love the military, but I don't love some of the stupid shit that we do, unnecessary shit we do. But when they ordered the 5,200 body bags and told us that it's going to be for, they said the exact area, they named off certain wards, and they said there's nothing that we're going to be able to do. This is going to be such a major flood that we're going to need these body bags. They wanted us to deliver those. So we get there, we deliver them.
How did they know it was coming to New Orleans?
It had to be ordered. See, just like there's a chain of command. Obviously, somebody informed at that time the governor, okay? And then the governor was like, okay, Big Brother, federal government, is just giving me some information. I got to act on it. Because if I don't, then Big Brother can step on me, stomp on me, you know. Believe it or not, although I'm half black, half Hispanic, people don't realize how the Confederacy was so more right than the Union. But anyways, so I believe he was given some information about something that was going to go down. And this is how we're going to support you. You just take what we're giving you. And so anyways, once he gets that order, he has to take it in front of Congress. I don't know if y'all, so, you know, a lot of things that they vote on and talk about, you don't ever hear about. You know, they go into their little secret little chambers,
right.
Don't even need the whole assembly.
Right.
Just get 4 of us to agree, you know, type thing.
Right.
But anyways, so we did that, and I found it strange that that was all they wanted us to deliver at that time. They weren't concerned about
supplies, or...
right. But the day we got there, I also found it strange. Although you do have at that time on Poland, it was a naval base. I found it strange that I kept running into. It almost seemed like 3 teams of Navy SEALs. And although as an officer I am privileged to some top security stuff, but I don't think that that naval research base is a training facility of theirs. Though I could be wrong because I have not know much about naval intelligence, but I just found that strange that they were there.
They were in anticipation of something.
That's what I believe.
This was how many days again before the storm?
Now, at that point now, because it takes a while to gather up all of those, and we were told to walk. We were told to work 24-hour shifts. So getting those things. So we fulfilled their order within right about 72 hours. So I would say this now marks us at about 8 days before the storm.
So 8 days before the storm,
5,226 is what we did.
5,226 body bags were delivered to New Orleans in anticipation to the storm, they were saying?
Yes, we were told that Hurricane Katrina was going to be they told us a Category 5.
Okay, that was when you got to New Orleans, they told you that?
No, that was, you remember the first briefing.
The first briefing.
So we already knew why we were bringing it
Category
up.
5.
Right.
But why New Orleans and not some other part in the Gulf? Or is that just where it was going to land? Or how were they so sure that it was coming to New Orleans 8 days out?
New Orleans was going to be the hardest hit.
That's interesting because...
They could predict that they said by the satellite they were using with a 210% accuracy of their prediction.
210 because they're driving it, in my opinion. But this is not something that I knew with 210%. There was like 2 days before the storm, I remember who was hyper aware of hurricanes because I was afraid of it because I grew up in LA where we had earthquakes. And when I came here and I heard about hurricanes, I was scared about it. But I knew we'd had the one the year before that was kind of like this false flag where everybody thought it was coming, but then it didn't come. And everybody was pissed off because they just spent hours trying to get out of town, but so there was kind of like this disarming. A lot of people were not kind of as anxious about it. And it wasn't until Saturday that I start worrying about it as I see people scurrying and I hear about it for the first time. I was busy. The first time I heard about it was the Friday before the Sunday that it came overnight, landed Monday morning landfall. So 3 days before, I didn't really know. I mean, that's when I became alarmed.
And it's strange because after we, delivered the body bags, I was expecting to get an order just to turn back and go back to where we were stationed at this time in Georgia, but then immediately we get an order to stand by in the event that we need to be of some service. But I was thinking, okay, why not just stay here at the naval base? I think at that time you also had Jackson Barracks, and the nearest military base would be Belle Chase, but they wanted us specifically to be about 100 to 150-mile radius out, but be ready at moment's notice to be able to come back in.
And was it just to the region or to New Orleans specifically? Like, come back, were they concerned about covering the region with body bags or New Orleans?
No, they told us leave those there, but
this was
they
for
wanted,
New Orleans.
Right, they did not want us to be in the city in the event when it hits, but to be within, for some reason they gave the Pacific, it was 100, they want us to be no more or no less than 112 miles out.
Okay. Well, that's interesting. And body bags, when you deliver body bags, do you normally deal in that count?
That was the most count that I've ever asked to have to load, and then the rush on them put a lot of strain, but it really tested my leadership. It tested the fellowship of my men and my team. It really, really was draining. Fights broke out. It was, just frustrating. It was, but we came together and we got. That's why they say just do it and get her done. That's what we're about.
Okay. Where did you deliver some of these other body bags to?
That's it. Just New Orleans.
No, but you said you delivered body bags.
I'm sorry.
Times.
Oh, of course, like during times of war in Iraq, and then of course with the already decomposed bodies of the women and children in Nicaragua. So, but we've had counts in the thousands, but never that high. That's why I automatically thought that it was another attack like 9/11 or the towers.
Now, have you ever had to bring body bags for other weather events? Was that the only weather event you remember bringing a body bags for?
This is something along with the help of usually your National Guard or Coast Guard units. We would be, of course, being the federal government on the federal level and then on the state level. Of course, we would have the more resources. So in the event so when they don't have those resources, we're there to be of support and things of that nature. So it's very common. So to answer your question personally, I'm quite sure that my personal attachment has probably been doing this for years, but this was my first time ever responding to an event like this. I thank you. Gives an opportunity for not only vets, but people who are just tired of being sick and tired of the lies, a chance to feel like a voice. And with that being said, I want to end with a quote of John F. Kennedy. Ask not what your country could do for you, but what you could do for your country. I did not get on the show with an intention to bash the United States military, none of the branches. I love Uncle Sam, although at times we could feel, and I have felt it, that he doesn't love me. It's not that I don't love the United States of America. It's not that I don't love the United States Army. I just don't like the lies.
Amen. Okay, we're going to get more specific than this, but just to show you preliminarily, Katrina moved in through here, made landfall through KLIX. We're talking about the eye, not the walls. And kept going up. KDGX, KGWX, here on the border before going up. So that is, again, 3 for 3 going in on NexRad. Dunk, 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 dunk. Okay, and we saw that with Irma. It's the same spot. It hit the same place in the Keys. All right. I don't know how they navigated over the waters, if they let it be, if they stir it some other ways. But when it comes to land, it comes home over NexRad. This killed friends of mine. Not at the time, but the year later, in the aftermath. I buried a lot of friends. I found one. I've been treated like an asshole by my loved ones in my community for caring about climate engineering. Partly because I also had partially incorrect narrative. Not totally, but narrative that would not allow me to actually come closer to proving it, because there's so many gatekeepers in this field. And this part was noticed and recorded later on because at the time I was so emotional at the confirmation of my suspicions that the storm that was the most personal in my life was indeed following the trend of following Doppler radar. But there were 2 more Doppler radars even before I started counting in Florida. Both were hit and were along the path.
It's because some of these people, this is a new normal. They're never going to go back home. So they want to help them as much so that they're never just walking out of here and feeling like they're going back onto the street. They've worked with them throughout the process here to help them adjust to this new world order that they're going to be living in after.